Hi, welcome back, learners, to our another strand in alkaline earth metals. Today we are going to talk about the ionic Radii and ionization energy of alkaline earth metals. You will find that number one, we will define what is ionic radius, very different from atomic radius. Number two, we will also talk about the ionization energy of alkaline earth metals. We will talk about what is ionization energy and how that ionization energy affects the reactivity of these metals. Let's start by defining what is ionic radius. Ionic Radii. Ionic Radii is the distance from the center of the nucleus of an ion, to the outermost energy level. We are talking about the ion. How these alkaline earth metals forms an ion. They form an ion by losing 2 electrons so that they become stable. Let's highlight those elements: beryllium, we highlight magnesium, we highlight calcium. We have said that beryllium, it has atomic number of 4. So you will find that it has an electron configuration of 2:2. When it forms an ion, it forms an ion by beryllium 2 ion. We have said that it loses 2 electrons to form a cation, divalent anion, a cation. Magnesium, it has 2:8:2. It loses 2 electrons to form an ion, which is magnesium ion, also a divalent. So the ionic configuration, you will be told to write the ionic configuration of this element. Ionic configuration of beryllium, it loses 2 electrons. These 2 electrons were lost, so it remained with two electrons in the first energy level. So it lost 1 energy level. Let's look at magnesium. Magnesium, it will remain with 2:8. 2 energy levels. 2:8. Let's look at calcium. 2:8:8:2. When it loses 2 electrons, it remains with 3 energy levels. So 1 energy level has gone with 2 electrons. So these elements forms an ion by losing 2 electrons. So you may find that the distance from the nucleus of an ion to the outermost energy level, it has reduced already, because you will find that the atomic size and ionic size, it is very different. Why? Because in atomic size, for us to make an ionic radius, it must lose 2 electrons with 1 energy levels. So it loses 1 energy level when it loses 2 electrons. So it forms an ion by losing electrons. So we have said that ionic Radii is the distance from the center of the nucleus of an ion to the outermost energy level. You will find that down the group, the ionic radius is increasing. Why? Because of increase in the number of energy levels. In beryllium ion, we have 2, which is 1 energy level. We have also 2 energy level. We have 3 energy levels. So we can comment and say like this: beryllium has smaller ionic Radii than calcium. Why? Because calcium has more number of energy level in its ion, while the beryllium has less number of energy level. So beryllium has 1, this one has 3 energy levels. So a question that you will find there, in exam, you will be told to compare the ionic radius of calcium and beryllium. So we have said that calcium has larger ionic radius. Why? Because of the number of energy level. What about the beryllium? Beryllium has less number of energy level, making it to have what small ionic radii. So in real sense, or when we summarize, we can say that ionic radii increases down the group. Reason, due to increase in the number of energy level down as you move down the group. So ionic radius, when you set a question on ionic radius, is very, very simple. You can be able to do that. Let's say, and say like this, ionic radius, ionic radii now increases down the group, reason, due to increase in the number of energy level as you move down the group. Energy levels as you move down the group. So we have said that calcium will have more number of energy level because it has 3. What about beryllium? It has only 2. So in terms of comparison, just compare first, then you give out the reason. The reason comes from here. Ionic radii increases down the group. So you can say calcium has larger ionic radius. Reason, because of the number of energy levels. Let us look also another thing, which is ionization energy. Let us also look at another term, ionization energy. Ionization energy is the minimum amount of energy. Minimum amount of energy required to remove outermost electron from the outermost energy level in gaseous state. So you will find that this is the minimum amount of energy required to remove the outermost electron in gaseous state. For example, we want to remove one electron. In magnesium. Is 2:8:2. For us to remove these 2 electrons, not all electrons will be removed once. We will remove in steps. One, the first electron, and the second electron. So in magnesium or these alkaline earth metals, we will have 2 ionization energy. And number 1, we will define what is the first ionization energy. Because we have said that minimum amount of energy required to remove the outermost electron, not electrons, electron from the outermost energy level in gaseous state. So we remove 1 electron per time. So as we remove the first electron, we say that is the first ionization energy. So you must understand what is ionization energy first. Number 2, you understand what is first ionization energy. Number 3, you must understand what is the second ionization energy. That is, we remove those electrons per time, not all of them. So we will define what is first ionization energy. What is first ionization energy? Is the minimum first ionization energy. So we add first. What is first ionization energy? Is the minimum amount of energy required to remove. So it is first ionization energy, minimum amount of energy required to remove the first the first electron in the outermost energy level, outermost energy level in gaseous state. Minimum amount of energy required to remove the first electron in the outermost energy level in gaseous. When you are being told to differentiate what is first ionization energy, define what is first ionization energy, you must include the first. Very, very different with the what is ionization energy. You must include the first electron in the outermost energy level in gaseous state. For example, in magnesium, it's an atom. We remove one electron. We remain with magnesium. It forms magnesium ion. So why are we writing like this? We have removed one electron from magnesium. So we find that this magnesium ion, let's note that the first ionization energy, let's say it is 570 kilojoule. 570 kilojoule. Let's come to the second ionization energy. You also say that second ionization energy is the minimum amount of energy required to remove the second. So I'm now changing the second ionization energy is the minimum amount of energy required to remove the second electron. Now we are coming to remove the second electron. Second electron, how is being removed? Second electron. So we come with the first energy in gaseous state. This one is in gaseous state. This magnesium is in gaseous state. We remove another one electron. It becomes 2 electron. So we are removing the second electron to form magnesium 2 electron now. And you will find that this process, it is in gaseous state to form magnesium. You will find that this process, it takes with a higher, let's say 770 kilojoule. So we want to explain. At the end of it, you will find that the second ionization energy is higher than the first ionization energy. Reason why? So you must be able to define what is second ionization energy and what is first ionization energy. Number 2, make sure you be able to give out a reason why the first ionization energy is lower than the second ionization energy. Let's give out the reason why the second ionization energy is higher than the first ionization energy. After removal of the first electron, the remaining electrons are greatly held by positive electrostatic forces of attraction. Yes. As we remove the first electron, the second electron remained. It is greatly held by the positive electrostatic forces. Positive electrostatic forces, these are forces that are holding the metallic or metals. We have something called metallic bond. Metallic forces. That electrostatic forces is the one that strengthens the metals. So as you remove the first electron, the second electron will be protected. The remaining electron will be protected by the force of attraction. You will find that forces of attracting the first electron now attract the second electron. So the force of attraction doubles. That force is called positive electrostatic forces. So the first ionization energy is lower than the second ionization energy. Reason, it is because after removal of the first electron, the remaining electrons are greatly held by positive electrostatic forces of attraction. So that is the main question you will be asked there. You will be asked there about why, when we remove the first electron in magnesium, the second electron to remove requires a lot of energy. It is because after removal of the first electron, the remaining electrons are greatly held by the positive electrostatic forces of what? Attraction. Let's come and talk about the ionization energy. So we are saying that the tendency of removing these two electrons, how does it differ all the way from beryllium to magnesium to calcium? You will find that the tendency of removing that two electron depends on the force of attraction. And also, you will find that the atomic size is now coming to affect ionization energy. We said that in beryllium 2:2, we will use a lot of energy to remove these two electrons. Reason? Because of the atomic size. The force of attraction is high. You talk about the forces of attraction holding the two electrons. What about in magnesium? We now use moderate or less energy than beryllium. And calcium, we will use less energy. So calcium has less ionization energy than beryllium. Reason? Because of the atomic size. So you will be told element A, B, and C. Element A, B, and C. Element A has 990 kilojoule. Element B have 570 kilojoule. Element C has 220 kilojoule. Which element is more reactive? You choose an element that has less ionization energy. That is the element that's more reactive. Number 2, you will be told which element has largest atomic radius. That is the element with the less ionization energy. Which element is less reactive? You choose an element that has high ionization energy. Reason? Because of the high ionization energy, small atomic size, high forces of attraction. Guys, welcome and be ready to learn to the next lesson will be chemical properties of alkaline earth metals. Let us be there. Let us join together. Let us enjoy our lesson. Thank you.